Guys, I've started the recording. Quickly, can you see my screen? Okay, cool. Okay, so let's start. What I'm going to go through is the paper that the guys wrote in June. So that we just work through that. I know there was nearly a memo or answers shared on it, but I think it's good that we work through it as well. The recording is going, so we will just basically, if you also want to look at it later, I have started the recording. Okay, and please stop me as we go through this. I think it is important that if there's anything still that we need to understand or need to get to, stop me and ask. Okay, so the question set for DSC 1520 for last semester, and I think that is also important. As we will, I just took now the first 15 questions, but basically you'll see it's not in order of your study unit. So I think that is the first thing that is important. It is not that study unit 1 is covered first and the last questions is on study unit 8. So I think that again for me is just important. So it can be that there are more difficult questions up in front. There can be confusing questions where you think you need to do differentiation or integration, but actually just substitution. So let's just go through this and see what we get. So the first question was nearly a maths question. So a line cuts the x-axis at 4 and cuts through the point 2 and 4. What is the equation of this line? Okay, so what I did is I was thinking, okay, so it cuts the x-axis at 4 and then it cuts through a point 2 and 4. So if that is 4, that is 2, that was 4. So you can see that if you sit with this line and you connect those two, that is somehow how the line will look like. So if the line is that shape, we know that your m or your slope will be negative. So before I look for going any further, negative, positive, negative, negative. Okay, so that can't be. Okay, first thing is option 2 is a no-go. If that is 4, that needs to be a bigger number than 4. Okay, so it can't be 2. You can see that it goes through something there, so that actually is also not because there's no x. So the only real answer that there was option 3, and this we haven't even calculated anything. So just by eliminating the ones here, I could get to the right answer. Okay, but obviously, if it was not like this, we still need to get to the right answer. So the first thing that I would do is I would write how my equation will look like. So sorry, that must be mx plus c. So the first thing is I would want to work out what the slope is. So the slope is normally the change in y divided by the change in x. So in this instance, we know they said to us that point was 2 and 4. This point was 4 and 0. So we could say the change in y is 0 minus 4. The change in x is 4 minus 2. So we have minus 4 over 2, which is minus 2. Okay, so then we already know that we are sitting with y is equal to minus 2x plus c. Then if we want to calculate the c, we can basically use that point or that point and put it into the equation. So let's put in the 4 and the 0. So x is 4. Y is 0. So we will have that minus 2 times 4 is minus 8. If I take it over to this side, it will become 8. So c is equal to 8. So my final formula is y is equal to minus 2 plus 8. Okay, which was the one that we needed to get there, which I basically could get without nearly working it out, but I just wanted to show you as well how to do it. Okay, so this is for me nearly testing that you know how to work out the slope, and then how to put that slope with a point back into the equation to get the final equation. Any questions on this one before we go and try the next one? So again, for me, I always like to nearly eliminate some of the answers. Yes, Tamarin. Tamarin, I think you're still muted. So
Yes. Okay. Sorry. Can you hear me now?
yes.
All right. So I just want to ask, at the beginning of the lecture, or this lecture, you said that the questions are not in the order of the chapters, or
Yeah.
did you say they are?
No, they're not. They're not in
Okay.
the order of the chapters.
Perfect. Cool.
Yeah. So that makes it a bit, I don't want to say difficult, but it makes you always wonder. Because if it was from the beginning to the end, then you nearly know where everything is sitting in the exam paper. So you would now suddenly see we've done this, and then the second question is a log question, and then we get something different that we need to maybe work out, and then it's a demand function, and then another demand, and then we go into linear inequalities, and then suddenly something different. So it's not not at all how we nearly not studied it, but how we worked through in our sessions and things like that. And it's not the first time all of the exams are like this. So your exam will be nearly like, not nearly, it will be like assignment free. And you will see that assignment free was a previous year's exam as well. So basically, the chances is very good that this year's assignment or exams will be next year's assignment free for the new students. So okay, so let's look at the log function. And here again, depending on the calculator that you can use, you can put this into the calculator. But we now nearly need to look at, so you can use the calculator. I just want to show what the log rules are. The log rules are, and that for me is how I will work it out on the calculator, is okay, so it's basically log of this thing divided by log of 3. That is how the log rule looks like. So it is 1073 divided by 7, which gives me 153.2857. So if I take ln of that, yes, we'll share that app now on the group, as I basically use this app even for other stuff. So the guys that haven't, I am putting the app now. We'll put it now on the, let me just quickly share app. Okay, so you must just check which of what the phone is that you need to download that app, because you basically scan the equation and it can work out the answer for you. I don't know if it can go into all of the other details, like the differentiation and integration, but you need to write it correctly and things like that. Okay, but here basically we would have said then log of the 153. So let's just do that, which will give me 3, and then log of 3 will give me something like 1.0986, and when I divide those two into one another, I will get option 2. So I will get 0, 4,5806. That will be rounded off to 4,581. Okay, so but basically I used the log rule to work this out. And I think that is the important thing. If you use your calculator, then you need to know how to use the brackets and those kind of things to get to the right answer. So let's get to the next question. So your Math Solver app that I sent you guys will be able to work this out, because you can take a picture of that. It won't be able to work this out because you need to unless you can write it down in a formula. But question 2 would have been able to work that out. Okay, so let's go into question 3. So again, probably your math solver will be able to solve this when you have set up your question correctly. First, what I'm looking at is always my answers, and then I'm like, okay, here's a minus 800, here's a plus 800. So I'm like between those two, and then find the number of paperback books that must be printed. So you need to get to Q. Then you know Q can't be negative. Okay, so I would have said option 3 is my answer. But let's put it in a formula. So they say it costs R2.50 to print a paperback book, and it costs R1 to bind the book. Okay, so your cost is R2.50 plus R1 per book. Okay, so we don't know how many books yet. Printing and binding setup cost are 1,000. So that is your variable cost. Your fixed cost is R1,000. And it doesn't matter how many books you print and bind, the setup cost is 1,000. Then they tell you these paper books are sold to retailers for R4.75. So basically, total cost equal to total revenue. So that is for the break even. So we can say total revenue is 4.75 Q. Okay, so then already on this side we have 3Q plus 1,000 is equal to 4.75 Q. I like to make everything positive, so I will take that to that side. So it is 4.75 minus 3 gives you 1.75. On this side, I had 1,000. So basically, to get Q, it is 1,000 divided by 1.75, which will then give you the 800. Let me just check again. Oh no, wait. So where did I now make a mistake? Where did I? So there. Sure, luckily there wasn't. That must be 3.5. As it is 2.5 plus 1, a bit of a silly mistake. So then that becomes, that is still 4.75. But when I take that over, it is actually 1.25. So 1,000 divided by 1.25 gives me 800. Okay. And then 800 is, thank you, Patricia. Yeah, silly mistake on my side. It is option 3. Luckily, there wasn't one for the mistake that I made as well. Okay, so this one was very simple, but you still needed to know to get to the break-even point. It is when total cost is equal to total revenue. I think that one was the important one that we needed to get here. Okay, then the next question. So now we're going to look at, consider the following graph showing the demand and supply function of a certain good. Which one of the statements is true? I've seen this in a lot of exams. I've seen this one in a few assignments as well over the last few years. So they so yes, so let's quickly, line 1 represents supply and demand. So that is the ladder, like you said in, what was it, study unit 3, session 3 or 2. Okay, so let's quickly look at the other one. That is not break even, that is equilibrium. So that's why it's not 2. Point B represents the minimum price consumers will pay. Here. It's on the supply, so no. And that is definitely not the minimum they will pay. So it's not that one. The area of a triangle ABC represents consumer surplus. Also not. Consumer surplus would have been that part. ABC is consumer surplus and producer surplus. So it is option 2, the ladder. Okay. Demand and supply. Okay, so and this one I've seen this numerous times in exams. So this is probably going to be in your exam this time around as well. Okay, so if you we nearly have 4 minutes. Okay, well, not we. You guys will have 4 minutes per question, because it's 2 hours, 120 minutes for 30 questions, so 4 minutes per. So these ones were actually quite simple to get each one in 4 minutes. So I don't think that is going to be a problem. Luckily now they've talked about demand and supply, so now they ask you a demand and supply curve. So consider the market defined by the following function: demand, supply, where P and Q are the price and quantity respective. Calculate the equilibrium price and quantity. So where those two are so that is basically where those two are equal, point A, that is where it will be in equilibrium price and quantity. So we need to say where the demand and the supply are equal. So 60 minus 0.6 Q will be equal to 20 plus 0.2 Q. Okay, so before we even go into there, I normally like to check. Okay, this is quite interesting. So there's 200, there's 200, 180, 180, 50, 50, 50, 50. Okay, so nothing that I automatically can say won't be the answer. But what is nice with these ones is if we calculate the Q now, we actually know what the Q is, and none of the Q's are similar. So then we have our answer. We don't even need to calculate the p-value. Okay, so again, I like to have all my Q's positive, so I'll take it to that side, so it becomes positive 0.8 Q, and on this side 60 minus the 20, so it becomes 40, so Q will be 40 divided by 0.8. And that is probably going to be Q equal to 50, but let's just see. So 40 divided by 0.8 is equal to 50. Okay, so we check where Q is 50. Option 1 is our answer. Okay, if you then put in back the 50 into Q, you will get that P is 50. Okay, so just if there was another option with Q in this that also was 50, the way then to get P is to use any one of those formulas, put back. So let's just do it for, so if we put it back into that equation, then it is 50 times 0.2, which would have given us 10. So P will be equal to 20 plus 10, which is equal to 30. Okay, so just if you need to, in the exam, if I give you an option of more than 1 Q that is equal to 50, just replace it in one of your formulas. It doesn't matter which one, and you will get then the P. Even if we put it into that one, it would have been 0.6 times 50 would have given us 30, and it's a negative 50, so negative 30 plus 60 will also give you 50. So just again, if needed, put it back into the original. Okay, so the first 5 questions was quite reasonable, I think, for the previous semester. Question 7 was an interesting one because question 6, because it's the first time that I see that them only asking one inequality. So yes, later on there will be more, but it's the first time that I've seen it in this format. So the thing that you need to do here is remember what it does, and I think that is the important thing, is nearly to say, okay, so I'm looking at this equation. How do I normally write my equations? So I think that is the important thing that you also need to think about. But before we even do that, let's just say, okay, so this is my okay, so I've written that down so that we can quickly just get some of the cuts, because otherwise it's going to be difficult to get that. Yeah, I would have guessed option 3. So let's quickly, so let's make if when x is 0, y is equal to 3. So when x is 0, y is equal to 3. So let's just okay. So not option 2. So just when x is 0, y is equal to 3. When y is 0, so when y is 0, it is, so let's write that equation. It is 3 plus 3x. Take that over to that side, so minus 3 is equal to 3x. So x will be equal to minus 1. Okay, so let's check. Okay, not that one, not that one. So that is the only one that basically can be, and it needs to be bigger than that. So all is fine. It is option 3. And I think that is nearly, so if you don't know the answer, guess option 3. But else, just by a quick look at where my points would be that I cross it, there was actually only one option, and that was option 3. Okay. So again, it looks very difficult because this is not something that we have seen in previous ones. We normally would see 3 or 4 of them. So this can sometimes throw you off as well because it's something new. But in actual fact, it was not that difficult to get to the answer that you needed to get to. Okay, quick check-in. Happy until now? Questions before we go to question 7? Okay, so let's continue with the next one. Okay, so demand function of a certain product is that determine the consumer surplus of a product if a market price is P equal to 90. Okay. Okay, so there's my demand function. Remember the ladder. So demand function is that one. So the demand function is 120 minus 3q. So that point will be 120. Okay, so determine the consumer surplus if a product price is 90. So if it is 90, we need to work out that consumer surplus. Okay, first we'll need to work out what Q is so that we can say, well, that area that I need to work out is half times base times height. So what we do basically is put 90 into that equation to get the Q. So 0 is equal to 120 sorry. Remember that is price minus 3q. Okay, so let me take that over to that side. On this side we have minus 30 is equal to minus 3q. So q will be equal to 10. Okay, so then with my formula I have a half times the base, that is 10, times that height. And that height is the difference, so it's 120 minus 90, which gives me 30. So it's a half times 300, so your answer will be 150, which is again option 3. Okay. If you don't know the answer, option 3. Okay, cool. So let's look at the next one. So now it's a bit more difficult because now you will see now suddenly it is a different type of formula. So the supply function is given by that. Determine the producer surplus if 10 units are supplied at price P. Okay, so I'm just checking with chat. Okay, so what would you have done in the what would you have done in this instance? Anybody except guessing option 3.
Hello.
Yes.
Hi, Jean. It's Patricia. Well, I worked with that differentiation one, the P times Q minus the differentiation of the supply function. And I got to option 2.
Okay, so you said...
I said P times Q, which was the 10.
Yes.
Times the 92. But the 92 I worked out when I put in the Q into the equation to get the 92.
Okay, so let's quickly, you put 10 in there.
Correct.
Cool. So let's quickly do that. So to work out the P, it was 10 to the power of 2 minus 20 plus 12. I'm just making it easier now to...
Yes, so it gave me a 92.
Okay, so that rectangle that we spoke about in the previous session would have been 92 times 10 to get that area.
Correct.
Which would gives you 920, and then you need to subtract the
Differentiation of the equation, basically.
okay, and that would have been...
With the calculator, 10 to 353.
Okay, so if we differentiate this, is it differentiation of this or integration of this?
What I did was I did that funny S, that big S, with a 10
Yeah.
at the top and a 0 at the bottom. And I said Q2 minus 2Q plus 12. I used the calculator.
Okay, so your calculator would have given you, let me quickly also, your calculator actually got you that.
Correct. Got me a 353.333.
Yes.
Yes.
So again, that for me is also just when you guys are, oh shucks. Okay, so here's two things that one needs to remember. So that one is nearly the only one. Sorry that I'm now saying that. So basically your answer will be 566.67. Okay, so if you stopped with that, you would have gotten 1. If you subtracted the 2, you would have gotten the right answer. If you added the 2, you would have actually had another option. So just, and I think that is just again how one, for me, how I tried to explain it I think it was last week. I can't even remember, days are blurred, but the full one that you then subtract. So just be wary of that if you add it, there's an option for the addition part as well, which is actually scary. I didn't even pick that up. Okay, so now you could see, and this is how they really like to do it, is you started off very simple, then they go into supply and demand and actually a straightforward definition. Then you had the break even or equilibrium one, then inequalities that nearly came in later. The simple consumer or the linear consumer surplus, and now suddenly in a non-linear producer surplus. So again, just want to say how they mix it up, because one is so trained that you get consumer surplus. Okay, the next one is producer surplus, so you nearly want to do it in the same format that you did the previous one. So I think that is just nearly how you need to be prepared for the exam, because now suddenly the next one looks like it can be again a simple formula, where it is just a demand and supply. So it's nearly they're trying to throw a curveball at you to just get you off nearly that. Okay, this is an easy one. We know it's a linear, and then suddenly non-linear. What do we do with a non-linear? And then the next one again is back to linear. So I just think again, nearly how to do it in the exam as well. Be very careful how they structure the exam, that the paper don't catch you out instead of anything else. Okay. So let's quickly, and this one again is nearly straightforward. So find the equilibrium price and quantity for the demand and supply functions. Okay, so again, I look at the answers and I'm like 4, 10, 16 free, 16 free. Okay, so maybe one of those two, 13, 12. But there's not one that if I get the price or if I get the quantity that I need to work out the price as well. So if I get the one, there's no duplication somewhere, so that is my answer that I can pick. Okay, so for me the easiest, the Q is equal to that, Q is equal to that, so we can say 24 minus 3P is equal to 4 plus 2P. We don't need to, there's nothing strange in this one. So again, I just like to take everything to the positive side. So this side, it's 5P. Take the 4 to this side, so it's 24 minus 4, which gives you 20. So 20 divided by 5 is 4. So I'm looking for where P is 4, and it is that one. And then automatically I can pick option 1. Again, if there was another one, say that was also 4, and now you're thinking, okay, which one? Then you just put 4 into any one of those two. So I would put it into this one. So then it is 4 plus 2 times 4. So that is 8 plus 4 is equal to 12. So that is how I then would get the Q as well. And you can put it into that one as well. 3 times 4 would have given you 12. 24 minus 12 is 12. So we got that answer. Just if needed, if you need to put the Q or to work out the Q as well. Okay. So yes, Dameron.
Can I just ask again about the previous one,
Yes.
the producer surplus thing? You made the consumer surplus question really easy for me when you explained that it's just you just work out the area with the half times base times height,
Okay.
right? But this was a quadratic equation.
Yes.
So like I just want to get more clarity on, okay, sure, I understand the first part of the P times Q. But the minus the area under supply line to the left of Q0 is the part that's
Okay.
not making them a lot of sense to me.
Okay. So it would be something like this. So what you would need to work out, and let me quickly, if I can remember now, sorry, I think that is the producer surplus part, if I'm right. So I just want to quickly check my notes. Or if somebody else can check my notes that I sent through yesterday. Let me quickly go on there. Please tell me I did. Otherwise, I'm gonna. Okay, no, there isn't one there. Then I'm quickly going to open the previous. So that I can just get it right for you. I just want to make sure which part I need to, because it's the full part minus. Okay, so I should have drawn it a bit better. Okay, so let's quickly erase this and put that into the and then I'll rather take my scribblings out. Okay. Okay, so basically how this would have also looked like is, and I've drawn it a bit wonkers, so because that's plus, that's minus, so say it was looking like something like this. So this one now goes through 0, but you basically will have that. So it doesn't matter how your graph looks like. So let's say even it's something like that. So this part is your producer surplus. Okay, so you working with this, you working out that whole part. Okay, and with this part, the integration, you're working out the part below that line. Okay, so I want only this part. That's why I'm taking so I want this part. So that's why I'm taking the rectangle, the bigger portion, and I'm subtracting that integration part that's below the line so that I can get my producer surplus. So once again, that one is a better drawing. So if you look at this, and we used this one, so your price would have been 92, your quantity would have been 10, so that would have been our whole area. But we want to get to the producer surplus, so the portion that I will need to subtract is this part below the graph. And how do I get that part? By the integration of that formula. Okay, so let's quickly integrate this. So how do you integrate this? What would you have? So quickly tell me if this integration is right. Q2. Okay, so let me. Okay, so that is what I would have gotten for my integration. So use to x. Okay, and then I would have, so if you put in 10 and 0, you would basically, doesn't matter to put in the 0, all will be 0. So you basically just put 10 into this. So 10 to the power of 3, I think, what is that, 1,000? So 1,000 divided by 3 is 333.33 minus 10 to the times of, okay, let's just do that. So 10 times 10 is 100. And on this side, plus 120. Because 10 times 12 is 120. So if I basically look at that, it would have been 333.33 plus 20, which would have given you that. Okay. Does that make a bit more sense?
So like, let me just get this straight. So this is this Q3 over 3 with the Q2 over Q2 over
Yes.
2 thingy, that plus 12Q. That's how you integrate a quadratic function.
Yes. So it was basically integration of basically PS.
And that and if I integrated this function, it would have given me 3533 or
Yes.
35. Okay, great.
Yes.
Cool.
Yes.
Makes sense.
Yes. So and the reason why you subtract it is because that part is actually sitting here.
Okay, cool.
So that part is this part. So that is why you're subtracting, because the 9 over 92 times 10 was this whole area. And because I want only PS, I need to say the whole area minus the green area. Okay, is that a bit better?
That makes a lot more sense now.
Okay, so, and what you can do in the exam as well is, if you get this question, copy this picture in for you, nearly, that you, or not copy, sorry, you can't, it's not a, but have this nearly with you so that you can see, but that is how we did it. So if I need to get to my producer surplus, that is how we do it. I think you guys can nearly, for yourself, out of a few of these things, get the things that's the easiest for you, how to calculate it and nearly structure something for yourself. Okay, happy with that?
Yeah, that's good. We can move
Okay,
on.
cool. Anybody else? Okay, Eva, you also now better with that explanation? Because I see you. Yes, okay, cool. Okay, so let's look at the next one. See, and now again they jump from integration into a normal supply and demand function. Now they go back to nearly, what was the study unit 3, maybe 4. So here now we are looking at total revenue, total cost, and profit functions. So firstly, how I would look at it is to say, okay, let's first get total revenue. So let's read through. A company produces X solar lamps at a fixed cost, so there will be my fixed cost, so we will use that in the total cost. And the variable cost, there we have that as well. So let me roll the, okay, so there's my fixed cost for my total cost function. There's my variable cost for my total cost function. Each lamp is sold for 300 Rand. Okay, so there's my total revenue. So my first formula that I'm looking at is total revenue is equal to 300 times Q. Okay, total revenue is for each lamp sold. I'm getting 300 Rand. So basically, then I know that 300 or my total revenue is 300Q. So I'm looking at these options. There's total revenue 300Q. That is not 300Q. So away with option 2. Total revenue 300. Okay, can be. Okay, so there will be an interesting between that and between that. Total revenue. Okay. So in the exam, I would have, before I even gone to the next one, I would have said, okay, option 2 and option 4 can't be because total revenue needs to be 300 times Q. Okay, so then my next one is total cost. So total cost is variable cost plus fixed cost, or fixed cost plus variable cost. So fixed cost was 5,000. Variable cost was 150 Q. So 150 Q plus 5,000 will give me my total cost. So total cost 150 plus. So that is correct. That is not correct. So option 3 is not. So even before we get to the profit calculation, we have what the answer is, and that's option 1. So the total revenue, the total cost, the profit we will get now. So let's just work out the profit, or the profit formula. So profit is total revenue minus total cost. So that is your profit. So total revenue was 300Q minus your total cost, which was 150Q plus 5,000. Okay, so let's just go on there. So that is 300Q minus 150Q minus 5,000, because the minus times the positives gives you a minus, which then is 150Q minus 5,000 Rand. Okay, so that is my profit function. So we know option 1 is correct. Okay, so here they say we're looking at questions 10 and 11. So let's just see what is in 11 that we maybe might able to use. So how many lamps were produced and sold if they made a loss of 2,000? Okay, so we know what the profit formula is. It is 150 Q minus 5,000. So now we need to say, so a profit is a loss of 2,000. So this formula equal to something will give me the answer. So what will it be? Will it be equal to plus or minus 2,000? Because for the plus there will be an answer, for the minus there will be an answer. So plus or minus 2,000.
I'd say negative because it's a loss.
Okay. What does the other guy say? Negative. Awesome. Okay. So it is negative. Okay, because it's a loss. So then it is basically 150Q. Always I would like to work with a positive, so take that over to that side. So 5,000 minus 2,000 gives you 3,000. So 3,000 divided by 150 will give you 20, which is also option 1. If you said positive, then when you took over the 5,000, it would have been 7,000. 7,000 divided by 150 would have given you the 47. So just again, make 100% sure. They told us it's a loss. That's why it is minus 2,000. Okay. So from this, if you calculated the profit function wrong here, you would have had this one wrong as well, unfortunately. The Scully method would have worked if this was correct. Then the Scully method would have worked. You could have, so if you had that, you could put in the 20 in Q and see what your answer is. Yes, it will work as well. Then you just hope that the 20 is not the last one, but the first one, that you don't need to go through all of them. But definitely Muhammad's Scully method would have worked in this instance as well. And it's nearly when, so I showed you guys now the total cost equation as well, but let's look at these. And so, and yes, I don't want to teach wrong stuff or to, but so we knew that one was the options. So if we look at this function, we know it is a variable cost plus a fixed cost. So here we have a variable cost minus a fixed cost. So that one would also not have been, so not even needed to work out that one. I would have automatically chose that one, because this one is wrong, because you're not subtracting your fixed cost, you're adding it. So by default, nearly you only had the top one. And because if that is right, that must be my profit function. So in a sense, you could have used nearly the Scully method here already, to say, well, I've worked out that one, that must be it. So it must be option 1. And if it is option 1, then that is my profit function, and I can use it into my next next equation. Okay. And all the other profit functions were in any case wrong. So it's not even that there was a other profit function that would have been correct. Okay, so let's look at, so in this one, if I nearly again needed to look at things that I needed to eliminate. So when I looked at the 92 times 10, which would have given me 920, then I know, because I am subtracting, it needs to be smaller than 920. So it can't be that one. So again, nearly just wanting to guide you guys, there's, like we did with this one as well, nearly as you go through it, you don't always need to solve the whole thing. You can nearly eliminate a lot of the options. So like in this one, so I'm nearly going to show, we don't need to probably calculate all of them, but to see with the least amount of them, can we get to the option? And then if you don't know the answer, you guess free. So question, and that is only for the ones that you don't know. Remember, don't always guess free, only for the ones. So this would have been a difficult one, so I would have guessed option free. But let's quickly check. Okay, so the first one that I always look at is the easiest one. So this tells me that my x must be bigger than 0 and my y needs to be bigger than 0. So my answer must lie in this area because x needs to be bigger than 0 and y needs to be bigger than 0. So this one automatically is not an option because here my x is smaller than 0, here my y is smaller. So I could already eliminate option 1 out of the equation because it needs to be bigger and it needs to be bigger. Okay, so I'm left with 3 options. So what you will see in this instance is all of them say smaller than. So nearly smaller than, smaller than. So we'll need to see between those two probably which one. But there's a negative there, so that can have an influence. So let's take this equation as the first one. So when x is 0, y is 13. When y is 0, x is 13. So when x is 0, y is 13. And when y is 0, x is 13. Okay, so let's see. So it is that line. So it is that line. It is that line. It is that line. But it's smaller than or equal to, so it basically lies to this side of that line. Okay, so it lies to this side of that line, so not to that side. So option 2 I can eliminate. Okay, so then if I guess, it is between 3 and 4. Because that's a negative, I first want to work with this one. So when y, okay, so let's first get when x is 0, y is equal to 4 because 3y will be equal to 12. 12 divided by 3 is 4. So if I look at this line, that would be, for both instances, correct. Then, ooh, there's a negative. So let's, wait, so okay. So so x was 0, y was 4. Okay, so when y is 0, x is equal to -6. Okay, so let's look for x0, y4, x0, y4, x minus 6, y0. Okay, so that is my line 3, and they tell me it's smaller than. Okay, so unfortunately both of them are still into play because it can be that one, it can be option 4. So both of them still into play. So then unfortunately I will need to look at this one. So 2x minus y smaller or equal to 8. So we need to rewrite it. I'll take that one over to that side. I need to make that positive. So out of maths, when I make that positive, that sign switches around, that becomes positive, that becomes negative. Okay. So equation 2, y needs to be bigger or equal to. So my equation 2, y needs to be bigger or equal to. It needs to be bigger or equal to. So then that one is not an option. It is this one, which is option 3. Okay, so because of that sign, we need to, when we simplify it, we need to make it positive. Otherwise, we can't get to the inequality area. And when we make that positive, that whole sign will change around. And that's purely maths. Okay, that is, so if x is that, and it will happen like that. So that is just purely out of math. So it is, so I think that is nearly something that you can nearly remember. That and we always want it to be written nearly in the format of y is equal to mx plus c. So, and we always want the y to be the positive one. So this was for me, in actual fact, a very difficult one in the exam because of that. And if you did it, if you kept it there as y smaller, you would have said y smaller, and then you would have picked option 4. Okay, so this was really for me a very difficult one in the exam, actually. Okay, so that was question 12. Are you guys okay with question 12? Or would you have just guessed option 3? Okay, so we've got a few minutes still, so let's see. I just want to finish the last 3 that we actually get through the first half of a paper. Okay, so now they're asking us if a demand function is equal to that, with P and Q, the price and quantity respectively determine the price elasticity. And let me roll it. The price elasticity of demand if a price is equal to 10. Okay, so what would you have done in the exam with this one? And if you guessed option 3, it would have been wrong. So what would you have done in the exam?
I'm having a problem with the different types of price elasticity. Whatever, I can't pronounce.
Yeah,
Anyway,
don't
so it's
worry.
like point
I'm
is
always struggling with it as well, so to pronounce it.
right. So there's like point price elasticity,
Yes.
and then there's arc, and then there's just price elasticity of demand. So what's what's the difference between when they ask you the point, when they ask you just the price, and when they ask you the arc?
See, I haven't, and I must be honest with you, let the bicycle just go past. I haven't seen in any exam nearly that they have asked for other two. So, to be honest, I haven't seen it. And if you look in your textbook, there's not a lot around for other two as well. So, but I will look at what the different formulas for that is again and quickly see if I can pick up anything. But
in the 2019 October-November paper, question 10 is determine the point of price elasticity of demand where P equals 51. And I couldn't get anywhere close to any of the answers that they gave me as an option.
Okay, that is quite interesting because the two are very similar. The arc one is different because you basically work out something different. That I must have it somewhere also. It was what, question 10?
Question, yeah, in the
2019 October November one.
Yeah.
Okay. Okay, I'll check for you. The answer probably was 3 in that exam.
Because they gave a quadratic demand function. It wasn't linear, and that's what makes it so difficult.
Okay. So the quadratic one, because then the point will be where because you will do the differentiation, and the differentiation will be a point, because it's where it's nearly a straight line will cut the quadratic. So that is where at that point they will work it out. Where with the normal demand and supply, because you basically work with the slope, it is seen as nearly between 2 points, but you're actually also working out a point. But the one on the quadratic is an actual point where it touches. So that's the difference between the two. And that is why with the quadratic one, you will probably need it to differentiate and then work from there. So let me check this one for you. This question is, where is my file? Because what would you have done in this instance? Because the more simpler function that you can work with. Let me just want to check where my, I don't know, wait. It must be on one of those five pages that I sent you. So let me quickly. Okay, so let me quickly, I've got one as this. So you guys must just tell me. So what would you have used? Basically this one in this instance or not? Can it be that? Can it be as simple as that? I don't, sheesh. 10 divided by 60 is actually, yes, 1667. So it will be, okay, cool. So Patricia, you also used this one. So just that A is a reference to the 70. Okay, so that is where the A. So the P is the price that they give us, the 10, and that A. So this is on, I think, on page 1 of the notes that I sent you guys. I will check if I did one for the, I don't see, but I've done elasticity for the quadratic, so I will just check where that can be, if I can just get something for you on the quadratic, because isn't that maybe one of the next ones? So that was the straight linear equation, and with a linear equation we can use that formula. Then with this one, the demand function of a good is given. That is quite where price is the P is the price and Q is the quantity. Find the price elasticity of demand at Q2 and say whether demand is elastic or inelastic at this level of output. Justify your answer. Okay, so what I also like to do is, let me just check even before I, so you guys have the notes so you can use it in the exam. So what I just always want to also draw myself before I even start, so -1, the +1, so anything to that point is elastic, anything between those two is inelastic. So bigger than 1 or smaller than -1 is elastic. So it might be this one. It can't be that one. Anything between -1 and +1 is inelastic. So it can be, so at least it can't be option 4. Okay, so how would you have done this one? I would have guessed. So what did you guys do for this one? If you would have gotten this in the exam, what would you have done except guess? Have anyone tried this at all? Or if you would get it now in the exam, what would you have done?
I'll use the learn thingy, I think, on my calculator.
I'm also now checking. Okay, so in your study guide, isn't this where you take a 44 to the other side and get ln of it? Okay, so okay, so what do I do? So you say take the 44 to that side. So divide on both sides by 44. Okay, the math solver will not fix that one for us. Okay, so there needs to be a formula for this. Let me quickly, because this is the non-linear elasticity. So what do you do with a non-linear elasticity? So Tamarin, you just said with the other one, basically you differentiated it or integrated the quadratic. You would have differentiated it.
I'm actually like, I never did this paper before, so
No. So
something with it, like, I don't know.
the question 10 one in the previous. So let's just, when you had the quadratic and you needed to work out the elasticity, you said something you would have differentiated or something like that.
No, you told me I should
Oh, what did you?
differentiate it, so I was like, okay, I'll try that. So
Okay, so what would you guys do if this is in the exam? Oh, I thought somebody's going to give us the solution. Yes.
Hi, Jacques.
Hi.
Sorry, in the laws of exponents, I think on the notes that you gave us, this equation would be similar to P equals 1 over 44e all to the power of 0.7 q. Is that not the first thing that you do?
1 over 44.
All equals to, e all equal to the power of 0.7 q. Isn't that the first point of departure?
Okay, so let's quickly see. And then that will be a positive.
Yeah, that would be a positive.
So let's quickly see. Okay. So let me quickly. See, I also, this is a difficult one for me also to, I just want to check in actually in this study guide what so that would have been nonlinear functions. Let's quickly see if I can get elasticity. Okay, next. Okay, so it was part of a differentiation. Yo. Okay. Okay, this is quite okay, so that's for one formula that they give us. And that's the other one. So let's quickly, I know we're over time, but let's quickly look at these two. So 1 over basically the differentiation of that. Oh, I hate this question. So the differentiation of that, let's quickly, again, is not easy. E to the power of wait, was it not? So nearly I'm now just No, it can't be just that. Oh, no, I thought it can't just be that. Okay, so we're missing something. So how do we differentiate this? And that's maybe something that so if we had e to the power of x and we differentiated it, it stayed e to the power of x. So is it okay? I will need to go and check this up, because basically we need to differentiate that, and if we differentiate that we can get to the answer, but I can't remember how to differentiate that. I actually can't remember, and I will probably use a online calculator to differentiate that. So let me I will just quickly go and check what this one is, and then I will bring it back onto the study, onto a WhatsApp group, because we need to differentiate that. But according to me, that is your differentiation rule. So it is like you said, must I take that minus and make it 1 over 44? So let me just check how to do that. Okay, let's quickly do the last one, and then I'll go back to question 14 tonight and send the answer to you. Well, I know what the answer is, so the answer should be option 2. So if anybody can get to me option 2, Patricia, did you send it to the group on WhatsApp or? Aha.
I went quickly to my Telegram to see if they had worked on it. And I'm just only seeing it now as well. They did choose option 2. I haven't quite gone through how they figured it out. But yeah, I've shared it to the group basically.
Okay, so, and they've used that formula.
They use dp over dq
times p over q.
Correct.
And and then they replaced that in there times p over q. Okay, so okay, so when you differentiate that part goes to the front of, so when we add, okay, so that is where the one that I couldn't remember. So if we add e to the power of 2x, it became 2e to the power of 2x. So that is where the difference came in. So you will need to multiply that with the 44, and then so we can say the differentiation. So we'll stop with this one. We can quickly do the next one tomorrow. So it will be minus 0.7 e minus 7 times 2. Okay. Okay, so that would be minus 30.8 e to the power of minus 1.4 . Okay, which gives you minus 7.5952. Okay, so let's just. Okay, so that's the one that we need to work out. And then, so that is the part that we did. So it is 1 over that. Five, 9, 5, 2 times P over Q. P we don't have yet, Q was 2. So how we calculate that? P is to say, well, we've got our original formula. We put in 2 there to get P, so it would have been minus 0.7 times 2 would have been minus 1.4. If we then set that is e to the power to minus 1.4 times 44, so P would have been equal to 10.8503. So then we know that is the value of P 503. So, and let's just quickly see, is it positive or negative? I just want to make 100% sure that, so it is positive. So 10.8503 divided by 2 times 1 over minus 7 points. So you can basically say divided by 7.5952 negative will give us minus 0.7143. Okay, which is option 2. So basically the important thing was, so for your that P and Q, we work with the original formula. So the Q was easy, they gave us 2. For that P, you need to substitute the Q, and then we need to multiply it with 1 over the differentiation. So the differentiation rule was the difficult one to remember, which I totally forgot. So the differentiation is 44 times the minus 0.7 to the power of minus 0.7 Q. Okay, so that differentiation, I totally forgot how to do that. And I think that was the biggest catch, is how I totally forgot how that you take the 2 in front as well. Yeah. Okay, so this was a really tricky one. But at least now we have the formulas to use for it. But we can quickly tomorrow look at this one again. Okay, if you're happy with that, we can quickly check it again tomorrow. But this is the process. So the thing that we need to remember with when it is non-linear is the integration, the differentiation of that formula. So they can give you any non-linear. So Tamarin, you spoke that it was a quadratic in the other one. So quadratic is a nice one to do the differentiation on. This one is difficult, I must say. I totally forgot how the differentiation was on the E function. So yeah. Okay. Thanks, Patricia.
How to do it. Like, I still don't really actually get it.
Yeah, so I will it was shared on the WhatsApp group as well. But I will explain it tomorrow again.
Thanks. Thank you. That'll be awesome.
Cool. Okay. Happiness, guys. This is the most difficult you will get. So that is, you don't even need to. This is the most difficult one, because this is the most difficult formula as well to do a differentiation on. So if it was straight quadratic, one normally knows what to do, but this is quite a different formula. Okay. Okay, then we'll do the rest tomorrow, same time, same place, and up until we're done. Okay, I'm gonna quickly stop the recording as well.